Hello students, so let us do certain numericals on this chapter 1 that we recently concluded, chapter 1. Now there is a problem in your specimen paper. The problem is something like this. So there is a mass of rock like this and it is given that suppose this is the center of gravity of that. First let me draw the complete diagram. So it's given that there's a piece of rock or something, and these are the forces being applied, and these values are the distances from the point of axis of rotation in meters. The question says find the net moment of force or the net torque. We have to find out that the net moment of force or the net torque. So first of all, let us identify the forces. Which one will be producing a clockwise moment and which will produce an anti-clockwise moment. So you see the 80 Newton force will make the rock rotate like this, that is in this direction. To make it rotate in this direction, which is anti-clockwise. So that's a positive moment of force. 50 Newton clockwise, so negative. 30 Newton will make it rotate in the clockwise, so negative. 20 Newton will make it rotate in the anti-clockwise direction, so positive. As for 200 Newton, since it is being applied exactly along the line of action of force and the point of axis of rotation, since they are coincident, since there is no perpendicular distance between the axis of rotation and the line of action of force, this force is not going to produce any rotation whatsoever. So therefore, what is the total anti-clockwise moment? What is the total anti-clockwise moment? You shall write the full, I am writing in short. Total anti-clockwise moment will be 20 Newton multiplied with 1 meter plus 80 Newton multiplied with 3 meter. So that's 240 plus 20, 260 Newton meter. That's the unit of torque. And the total clockwise moment is equal to 30 Newton into 4 meters plus 50 Newtons into 5 meters. So that's 120 plus 250 Newton meters. What is it? That's 370 Newton meters. So we see the clockwise moment is greater than the anti-clockwise moment. Therefore, the net moment of force is in the clockwise direction, and that is equal to 370 minus 260, that is 110 Newton meter. So the final answer that you will write is that the net moment of force, so the torque, is 110 Newton meter in the clockwise direction. So this is one type of sums that you may face where you are asked to find out the net moments. There's another kind of sum. This was probably in your exercise. It was given that there is a meter rule, and the meter rule is at equilibrium when placed over a fulcrum which is at the 30 centimeter mark, and that a load of 40 GF is being hung from the 5 centimeter mark. So a fulcrum supporting the entire meter rule at 30 centimeter mark, and there is a load at the 5 centimeter mark. Question says find capital M, which is the mass of the ruler. Now you should know one thing, that whenever the question says that a ruler is a uniform meter ruler, the mass always acts at the center, that is 50 centimeter mark. This is where the mass of the ruler multiplied with the gravity will lead to a force, always at the 50 centimeter mark, that is at the halfway mark. So if it's a 50 centimeter ruler, this will act at the 25 centimeter point. So this is producing, 40 GF is producing a anti-clockwise moment, the mass of the ruler is producing a clockwise moment, and since both of them are getting balanced, it's being loaded completely at equilibrium at the 30 centimeter mark. So you will write like this, that by principle of moments. Anti-clockwise moment is equal to clockwise moment. So what's anti-clockwise moment? That's equal to 40 gram force into 30 minus 5 centimeters. So the point where it is at balance minus the point where the weight is loaded. So that is basically this distance. You have to multiply the line of action of force with the perpendicular distance. And this is equal to the clockwise moment, which is equal to mass of the ruler in gram force. So then I don't have to multiply G, and 50 minus 30 centimeter mark. So this is 25 into 40 is equal to, this is 20 into capital M in GF. The zeros cancel, 2 cancels, so the mass turns out to be 50 gram force. Gram force is a unit of force, so rather I should write that mass M is equal to 50 gram. So that's the mass of the ruler. Now this is the kind of problem that you may as well receive. There can be slight variations, but overall this format shall be maintained.